hello everyone. عسلامة، مرحبا بكم اليوم في ايفنت آخر باي جي دي جي سوسة. اليوم عنا كلاود نيكس اكستندد. مانيش باش نكون وحدي، باش يكونوا معايا جروب from strategic Google Cloud في جوجل India. I'm gonna start by introducing myself. أنا ابتسام حتى MLOps engineer organizer في الكوميونيتي المزيانة والباهية على الآخر اللي هي جي دي جي سوسة Women Tech Maker Ambassador. اليوم I'm gonna just باش نكون هي بالاوبننج كينوت، وبعتالي فما ديسكشن باش تصير على تولك اللي باش يصير باي الجوجلرز، و ام جاست باش ناخذ الكيو ان اي نتاعكم كان فما سام كويستشنز والكل. حاجه نحبوا we celebrate it today اللي هي 10 years anniversary of GDG Sousse. GDG Sousse اللي هي Google Developer Groups Community. عندنا 10 سنين of hard work، 10 سنين of achievements، 10 سنين events، 10 سنين contribution، workshops، talks، 10 سنين واحنا نعملوا في contribution في الكوميونيتي، 10 سنين احنا we share الكنولج نتاعنا we share with you الجوجل تكنولوجيز النيوز and so on، وكل شيء نحبوا نحاولوا نخليكم updated والكل. اليوم 10 سنين we are celebrating this الشهر هذايا في ديسمبر. نحب نقول أول حاجة big up للتيم اللي بديت من 2013 لليوم من 2023 موجودين. بديت بوان اورجانيزر، انت لليوم وصلنا ل 18 اورجانيزر. ويس مش باش نمنشوني الناس الكل، but you can maybe تدخلوا البلاتفورم جي دي جي سوس، تلقاوها على جوجل ديفلوبر جروبس، نجموا تلقاو الغادي الاورجانيزرز الكل، تنجموا تلقاو الديبارتمنتس شنو هما، الايفنتس الانونسمنت نتاع الايفنتس، وزيدا تنجموا تلقاو maybe تصور ولا moments من الحاجات اللي صارت قبل. You can reach out to us anytime if you have any questions، حاجات you need help في أي حاجة، في أي جوجل، في أي تكنولوجي تبع جوجل. Cloud Next اليوم event جديد by جي دي جي سوسة. Cloud Next هو mainly البيج event اللي جوجل تعمل فيه الاناونسمنت نتاع النيوز والنيوز والابديتس اللي في الجوجل كلاود السيرفيسز and so on. عام سنة، واليوم حبينا نعمله جوجل كلاود اكستندد انه باش ناخذوا اللي already mentioned ولا announced في الكينوتس في اللي كان في والا في اللي announced في الايفنت في سان فرانسيسكو، واحنا باش ناخذوه بلهجتنا بلغتنا we introduce it simply للكوميونيتي. السنة اكسبسيونيلمون كان فما اكثر من 161 حاجه صار الاناونسمنت نتاعها. maybe we can start by data و AI cloud in general. duet AI اللي هي كانت maybe أكثر حاجة صارت الاناونسمنت نتاعها سنة وصارت عليها فوكس كبير. كيف الجنراتيف AI models by جوجل، منهم Palm 2، منهم كودي اللي that will helps you برشا في الكودينج. Palm 2 اللي هو generative AI model، so يخليك you generate maybe هو integrated في الجوجل services والجوجل الحاجات اللي تستعملوهم كل يوم، كسوا جيميل، جوجل سلايدز، documentations and so on, so integrated there. برشا حاجات أعطت لما جوجل سنة أكثر لليوزرز وإلا للديفلوبرز أنهم they use أكثر Vertex AI platform. Vertex AI platform it's basically MLOps platform اللي تخليك الغادي تراني maybe وتتريني وتعمل البروسيس الكل ولا البايبلاين الكل اللي يصير للديفلوبمنت متاع machine learning model. نبداو من الداتا انتل الديبلويمنت، داتا تريننج، التيست متاع الموديل، البريدكشن، الفاين تيونينج، كل شيء متاع الموديل يصير سو على البلاتفورم فيرتكس اي اي. زيدا كيف الاناونسمنت كان الكود لاب انتربرايز. فما برشا حاجات اوكي ديديي maybe اكثر les entreprises ديديي للستارت اب ديديي للبارتنرز نتاعهم but انت as a developer you can just معناها go للويب سايت الغادي تاع جوجل كلاود you can try some services you can use it. اوكي زاد كيف فما الاناونسمنت نتاع الميد بالم 2 اللي هو generative AI model ديدي اكثر للميديكال maybe field والكل. كنا عملنا الاناونسمنت في الايو اكستندد سنه في الصيف نتاع البالم 2 هكا معناها حكينا عليه على كيفاش how to use it شنو هما الفيتشرز اللي موجودين الغادي so you can try it and yeah. second maybe field ولا announcement big announcement هو اللي كان data analytics كان فما البيكويري ستوديو فما كيما البيج ليك زاد كيف كان فما الجوجل كلاود الجوجل ديستريبيوتد كلاود داتابليكس and بيكويري داتا كلينز روم كيف كان فما كيما قلت لكم زاد الاكسس انه يتراي بالم 2 على فيرتكس AI using BigQuery. حاجة أخرى اللي هي databases. فهي regarding databases كنا عملنا الاناونسمنت في الايو extended على الالوي database. اليوم زادوها أكثر features زادوها أكثر maybe performance and scalability so ولات الالوي database AI تاخو maybe الحاجات القوية ولا الباورفul features الباورفul functionalities اللي موجودين في البوستجريس SQL as a database so maybe you are using it. Before I move just راهو you can تدخلوا على اللايف متاع جي دي جي سوس في اليوتيوب channel في جي دي جي سوس and you can ask me there if you have any question so I can answer it. به فما زاد cloud spanner data boost فما auto generated key in Google spanner زاد كيف فما الميموري ستور والريديس for redis cluster فما الجوجل ready for cloud SQL. You can you can maybe use other services to easily you change the streams and yes maybe next we're gonna go for business intelligence زاد كيف integrated فيه في البلاتفورمز اللي that you can use فما زاد duet AI اللي هو already integrated and for modern cloud and infrastructure modern cloud and infrastructure سنة كان فما announcement أكثر شيء على TPU اللي هما tensor processing unit اللي هما ديدي maybe أكثر أنه تجم كما لي سي بي يو كما لي جي بي يو مي لي تي بي يو سون حاجه performant اكثر used by AI startups AI companies to train their models to deploy their models there so yeah كان فما announcement في infrastructure for AI workloads فما في الcompute tradition enterprise workloads networking distributed workloads modern container and based workloads and developer experience migration and management and يمكن من أقوى الحاجات اللي أنت كديفلوبر ولا كيوزر للجوجل services and technologies and Google workspace itself هي الانتجريشن of ال AI سنة كانت so I maybe this is it so سنة كما قلت لكم it's the AI year for Google. I invited معايا اليوم التيم في جوجل إنديا اللي هما responsible في emerging practices منهم strategic cloud engineers منهم cloud migration engineers so yeah I will invite Tanya to the stage so to share with you her experience هي والتيم متاعها so yeah hello Tanya you are on the stage.
Yeah, hi everyone, and thank you so much for your warm welcome. So, yeah.
Thanks for you,
So
Tanya, and your team. Thanks for sharing with us your knowledge and with the community. Thanks for your commitment and contribution today. So yeah, the mic is yours. You feel free maybe to introduce yourself, your team, and then I will bring you the slides to the stage.
Thank you so much. So I and my team are working on Vision API in Google, and we have been like doing this work since last 1.5 years. And like actually, my Shivank and Utkarsh are my seniors who have been doing this work like since they joined Google. That was around 2.5 years back. So we are just continuing and following their directions and. Yeah, but I'm really sorry that the rest of the team is not available here since it's like very late in India. So I am here to represent from my team side. So I'll give quick introduction of myself. So my name is Tanya Sharma, and I'm a strategic cloud engineer with passion for innovation and with 1.5 years of hands-on experience, particularly in the dynamic realm of Google Cloud. And I've had the privilege of navigating and implementing cutting edge solutions. And everyone today join me in the unrevealing the transformative power of Vision AI and exploring how it aligns with the evolving landscape of cloud technology. Let's go through the Vision API, what it has, and
Uh-huh.
how it can change things. Yeah. So wait. Change the slide. So this is our
Is
agenda
this
for today. And
okay? Okay, Tanya, yeah, you
yeah,
can do.
okay, wait. Yeah, so Google Cloud Vision AI, it's a powerful tool for understanding and analyzing visual content and transforming how we interact with the images and the videos. So coming on to the next slide. Yeah. Vision AI is advanced image analysis for it's a advanced image analysis tool that utilizes machine learning models to recognize and understand the contents of the image. It allows developers to integrate powerful analysis capabilities into their applications without the need of extensive machine learning expertise. And developers and businesses across diverse industries have integrated GCP Vision AI into their application to enhance user experiences and offer more sophisticated image related features. So it has been leveraged in e-commerce for product recognition, in healthcare for analyzing medical images, and in entertainment for content modernization, and in various other sectors to obtain valuable insights from visual content. And the ease of use, seamless integration through APIs, and the accuracy of image analysis have made GCP Vision AI a go-to solution for businesses seeking advanced image recognition and understanding capabilities. So coming on to the next slide. So we have like Google, we have the response from the Vision API here. So it's basically like the response we get is supported in different languages, and it provides like explicit content detection, which is very crucial for moderating or filtering inappropriate content within images, and object detection and tracking features assist in identifying and outlining specific objects within the images. And developers can access Vision API through user-friendly APIs, and as you know, it's supported in various languages and various file types, so we can use it with different data format. So it's really a one-stop solution for all the images we have. So now coming on to the features we have for the Vision API. So these are the different features that we have for the Vision API, coming like face detection, logo detection, label detection, explicit content detection, OCR, and lead mark detection. So first we have with us is the label detection. Second. Yeah. So basically, labels can identify general objects, locations, activities, animal species, products, and many more things. And a label detection response includes the detected labels, as you can see in the image that we have, and their score, a topicability, and an opaque label ID, where we have mid, if present, contains a machine-generated identifier corresponding to the identity's Google Knowledge Graph entry. We have description, the label description, the score, the confidence score, which ranges from 0, that means no confidence, to 1, which means very high confidence, and topicability, the relevancy of the image content notion label to the image. It measures how important central a label is to overall context of a page. So if you need targeted custom labels, then Cloud Auto ML Vision allows you to train a custom machine learning model to classify images. And labels are returned in English only. And we may work on different languages, but for now it's just for English. And now coming on to the next one, that is the logo detection. So logo detection is basically like the Google Cloud API is trained to recognize a wide range of popular logos across various industries. And the API is capable of detecting multiple logos within a single image. A logo detection response includes logo and a associated description, confidence score, and a bounding polygon. For each logo detected, the API provides description, that is the name or a description of the logo identified, a confidence score, as that was in the label detection. It's same as that. That is a confidence score that obviously indicates the likelihood of the detected logo being correct, and a bounding polygon. Like this information is useful for determining the precise position and size of the logo within the image. So that we had for logo detection. Now coming to safe search detection, we have so safe search detection basically categorizes into the following categories, as you can see on the screen. We have adult, spoof, medical, violence, and racy, and returns the likelihood that each is present in a given image. And these likelihood levels indicate the degree to which the Vision API believes the content falls into each category. The likelihood levels include the following values. So, uh, very unlikely, this means the content is highly unlikely to be within the specified range it holds score of. The second one is unlikely. The content is unlikely to be within the specified category. Possible, likely, and very likely. As you see, I'm not explaining this since like it's very obvious here. And more like for more if information, we can go through the Cloud Vision API official website that we have, on which you can find more information about this. Coming on to the next one, which is the landmark detection. So, landmark detection in the Google Cloud Vision API is a feature that allows the identification and recognition of prominent landmarks within an image, and it enables the API to analyze visual content and pinpoint specific locations or structures that are well known or iconic. So, for example, if you provide an image containing a famous landmark such as the Eiffel Tower or the Statue of Liberty, the landmark detection can identify and label the specific landmark in the image. And this capability is valuable for applications in tourism, image categorization, and geolocation services. So, in summary, landmark detection in Cloud Vision API is a functionality that automatically identifies and tags recognizable landmarks within images, offering a powerful tool for image analysis and content understanding. Now we have uh, face detection. So, face detection basically helps to locate faces, bounding polygons, and identifies specific facial landmarks such as eyes, ears, nose, mouth, etc., along with their corresponding confidence values. It returns likelihood ratings for emotions like joy, sorrow, anger, surprise, and general image properties like underexposed, blurred, headwear present. And likelihood ratings are expressed as six different values: unknown, very likely, and unlikely, possible, likely, or very likely. So this was for the face detection. Coming on to the last second one, we have web entity detection. So yeah, web entity detection features searches and identify image references that are either similar or identical. So the web detection features offer six different types of information that are listed here. So the first one is web entities that returns a list of recommended tags associated within the image. And these tag values can be label, brand, logo, depending on the extracted information from the image. The next we have is the full matching images, which identifies identical to the image sent in the request. Next one we have is the partial matching images, which identifies partially similar to the image. Pages with matching images, which returns website information that contain images identical to the image present in the request. Visually similar images returns a list of images that are similar to the image. And best guess labels that returns label name that can be used to identify the image. And coming on to the next one, that is the one of the popular ones, that is OCR. So optical character detection. So that in context of Google API, this refers to capability of the API to identify and extract text content from images. And this powerful feature allows the automatic recognition of printed or handwritten text within pictures. And with OCR, the Cloud API can analyze images containing text, whether it's from scanned documents, photos, or other visual content. It accurately extracts the textual information, making it very accessible for further processing and for translation and for any other application that requires understanding and working with text data. So, in summary, OCR with Google Cloud Vision API enables the extraction of text information from images, providing a valuable tool for tasks such as document digitalization, content indexing, and data extraction. So, this was about the features that Cloud Vision API has. So, next, coming on to the use cases that are associated with the Cloud Vision API. Yeah. So, like there are various use cases of uh, Cloud Vision API. The first one is find products of interest with images and visually search product catalogs using Vision API. As you can see in the image, like we have a mobile phone, and we like with the help of Vision API, when we upload image containing the apparel we want and give it to Vision API, it stores the data in cloud and fetches the information we wanted to get. Like this only, we have multiple examples of Vision API that you can also find in the official documentation on https cloud.google.com/vision. For more information, we can jump to that. So we have different use cases, like it detects logo, as we discussed, logo detection, and it also searches logo. We give image to it, and it starts searching for the logo. We have multiple object detection. So we suppose we give photo of a dog, a cat, and a person. Uh, so it identifies the images and tells us that as you can see in the image, there's a person, there's a dog and a cat. So it has given the percentage of the people present in the images, like how much percentage of the face of this thing present in the image. Coming on to the next, that is understanding and analyzing faces with images. So it it takes the photo and analyze the the emotion on face of people. As you can see, it has in the image you can see. Also, uh, we have a live working demo of this of all of the use cases. So I'll be sharing it also during the presentation. Coming on to the architecture. So this is the architecture for the Cloud Vision API that we have. So as you can see, we have different paths. The path is from user to GCS, from GCS to Cloud Run, from Cloud Run to Vision API, and from Rundown to BQ. And this is the basic architecture that uh, the API has followed. And it's like if you see in the uh, code-wise path, it's like the initial title is the Vision API image processing, and you can see that there are different elements like card users as users and display name users. Then we go to the GCP part. Then the card storage in GCP, they store the data as cloud with the name cloud storage. And we have the image trigger after that. And after the image trigger, we pass it on to the Cloud Run job with the description. And then it gives to the Vision API, which generates a big query table. So that was the architecture for our Vision API. Now,
Maybe
um,
I have a question. The last slide, the previous slide. Sorry, for the cloud scheduler. What is the main purpose of using the cloud scheduler?
in the architecture,
Yeah.
so wait just a second. So basically, scheduler, it allows us to manage all of our automation tasks in a single place. So when the data comes, so it manages all the tasks and automate it's and manage everything in one place.
Okay.
So
Mm-hmm.
that
Okay.
is
Thank
for
you.
managing the jobs. Yeah.
Okay. Thank you. The demo.
Yeah.
So
Yeah. So I'll be starting the demo now for the Cloud Vision API. Is it visible to you?
yes. 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 We can
Sure.
see it.
Okay.
Maybe Tanya, the sound of the video is not here.
Pardon? Sound is not there.
Yeah.
Let me check how we can share the sound. Um, I'm not sure how to play the sound for the video.
Um.
Just a second.
Mhm.
Wait. Wait. Should I open it in a other window and try it?
Okay. Yeah. Maybe it will be better. Outside
Yeah,
the
just
slide, if you have it locally. Yeah.
yeah, I do have it. So is it audible now? Is it audible?
Mm, mm, mm.
Yeah,
Yeah. Yeah. On
just
the
a
view. Yeah.
second.
On the view. On the view. Yeah. So just.
Is it fine now?
Mm, no, the sound is not yet coming.
So maybe I'll have to share the tab and then it will be audible. Should I like I'll stop
Okay.
sharing once and I'll reshare it.
Okay.
Just a second.
Or I will do my site. Maybe I can download it and. Okay. 1 minute. So
So it's a
maybe
video. It's
it's not going on.
Okay, yeah, got it. How to share it. I'll have to share a tab, then only it will be audible.
Maybe, or you can just send me the link of the video in the drive so I can download it and maybe put it again in the stage.
Sure.
Yes, the easiest way. You can hear
Uh,
in the
here,
chat.
sure.
Yes.
Is it like, do you have the access? I'm not sure if you have access for this. So,
Just from the right of the screen, you have comments, so you can put. Okay, yes, I have the link. Okay. Mhm.
are you able to access it?
Download it anyway. Yeah. Okay. Maybe it will take some time.
Actually, I have
Um.
downloaded it, so I can share it with you. Is it
Uh,
visible?
yes. Okay.
We have
So
seen what is Google Cloud
let me
Vision
check.
API,
Just
why to use it, its benefits and features. Next we'll check on how to use Google Cloud Vision
I
API to
don't.
detect features from an image using Python. Before that we'll check on the try it option provided by Vision API. This is a web-based interface where we can upload images and get the results in real time. I have already uploaded this particular image to be annotated against from Vision API, and these are the following features that are identified for this image. Within objects we have a person object, a clothing object identified for each person present in the image along with the confidence score. Within labels we have these labels like water, sky, people on beach, people in nature, happy, and other labels along with the confidence score of them being in the image. Within logos, Vision API is able to identify Getty images from which this image was downloaded from. Within text, there are two text blocks identified. We also get the information of exact location of this text being present in the image. Within image properties, we get the information on dominant colors present in the image. Within safe search, we get attributes like adult, spoof, medical, violence, and likelihood of them being present in the image. We also get information on the request and response objects of Vision API. Coming to request object, we have requests field which contain list of one or more objects of type annotate image request. Each of this object contains features field which contains a list of features that needs to be annotated against the image. We specify the type of the feature along with the maximum results. We also get image field in the requests object which contains the content or the data of the image that will be processed by the Vision API. Coming to the response object that is returned from the Vision API, we get information on the labels or the features that are detected from the API along with the information like description, MID, score, and topicality. Basically the information in a structured format. Prerequisite, we need to have a Google Cloud Platform project created with billing enabled. Next we need to enable the following APIs: Cloud Vision API and BigQuery API. The information extracted for an image using Cloud Vision API is stored in BigQuery table. Next we need to set up the authentication and access control. This can be achieved by either creating an API key or creating a service account with required permissions and by downloading the private key associated with it. As we are using Python, we need to install the client library provided by Vision API for it. This can be done by executing the command pip install Google Cloud Vision. Next, we will look into the ways of providing the image in the request object sent to Vision API. If the image is present locally, you can pass the image data by converting it into a base64 encoded string. The encoded string value is passed in the content field of the image. If your image is present in a Google Cloud Storage bucket, you can pass the image URI associated with the image object. The value can be passed in the image URI field of the source present in image. We can also pass publicly accessible images by passing the HTTP or HTTPS link associated with the image. The value is passed in image URI field of the source present in image. Now we will see how to process the images using Vision API in Python and store the results in BigQuery. I have the Python script handy, so I'll paste it over here in the editor. We have the main function over here and a list of images. There are different types of images like PNG and JPG, and also images which are present locally, image which is present in Google Cloud Storage bucket, and images which are publicly accessible and available. For each image present in the list, we'll be calling the function annotate. This function takes image path as input and outputs the annotated image response from Vision API. We will now look into the function definition of this function. Annotate function, we first import the module Vision from Google Cloud. This module is installed by running the command pip install Google Cloud Vision. Next, we create a client for Vision API using image annotator client object. Using this client, we will be able to create a connection to Vision API and send requests to it. Next, we create the image object. We first check whether the image path starts with either HTTP or JS, which indicates that the image is either present in Google Cloud Storage bucket or a publicly available image. In this case, we create an image object of type Vision and set the image URI field to the path of the image. In this case, the image path contains the URL of the image. Else, if the image is present locally, we read the bytes of the image and the read bytes are stored in the content field of the image object. This is how we structure the image. Once the image object is created and structured, we will be passing this image object into the image field of the annotate image request class. This class is used to create a request to annotate the image using the Vision API. Once the request is created, this request is sent to Vision API using the annotate image method present in the client. Vision API, on processing the image present in the request, it then sends back the annotated image response containing the features detected for the image. While processing, if the Vision API encounters any error, the information can be found in the error.message field. Next, we will be returning the response which contains the annotations for the processed image. After receiving the annotated image response for an image from Vision API, we then store the response in BigQuery table. In order to do so, we will call the function getResults and pass the Vision response and the image path. This function structures the annotations received from Vision API into a format suitable for storing it in BigQuery. Once the record is created, we then call the function write to BigQuery. We pass the image path, image record that is created, and table ID. Table ID represents the ID of the BigQuery table that is created. Next, we import the library BigQuery from Google Cloud. And then we structure the data in order to match with the schema of the BigQuery table. Next, we create a BigQuery client in order to connect or create a connection to BigQuery from the Python script. Next, we use the function insert rows JSON in order to insert the record into the table. We can either specify a single record or a list of records. So this is the overall process of the Python script, starting with creating a client to Vision API and then structuring the image object and passing the image object into the This annotated image response is then structured in order to store it in the BigQuery table. One of the image that we send to Vision API for annotation detection using the Python script that we discussed earlier. In this image, we can see that there are two people riding the motor bicycle. There are mountains in the background. There is trees in the background. So now we will look into the information that is extracted from Vision API for this particular image. This is the response that is returned from Vision API for this particular image. We have face annotations detected from Vision API. This annotation includes bounding poly. This provides a coordinates that helps us to locate the face in the image. Next we have FD bounding poly. This is tighter than the bounding poly and encloses only the skin part of the face. Vision API also detects specific facial landmarks like left eye, right eye, left of left eyebrow, right of left eyebrow, and provides the position of it on the face. We have such features detected over here. Next we have emotional attributes detected like joy likelihood, sorrow likelihood, anger likelihood, and surprise likelihood, and each of them have a likelihood rating assigned. We also have image properties that are detected. So we have information like whether the face is blurred, whether they are wearing any headwear. So here we have very likely rating for headwear likelihood, and as you can see in the image, they are wearing an headwear. We also have another bounding poly which identifies the location of the other face that is detected. In the similar way, we have information like FD bounding poly, the landmarks that are detected, and the emotion attributes as well as the image properties. Next we have label annotations. In label annotations, we have information on MID, description of the label that is detected, score that is assigned to this label, and topicality. We have labels detected like sky, tire, smile, wheel, vehicle, plant, automotive tire, mountain, and other labels. Has also detected safe search annotation, and it has the attributes like adult, spoof, medical, violence, and racy. And for each of these attributes, there is a likelihood rating assigned to it. We have the likelihood rating very unlikely assigned for all of these attributes, which resonates with the image. Next we have information on the image properties annotation. Here we get the general image properties like the dominant colors present in the image. Next we have web detection. Here we get information on the detected web entities and web images. Vision API serves to the web to find images which are partially matching with the image or completely matching with the image. It also identifies the keywords which are present in the particular URL or in the link. So we have information on the web entities like stock photography, image, Getty images, photograph, and we also have the score associated with each of the detected web entity. Next we have partially matching images. So if I click on one of such link over here, so we get this particular image, and Vision API is able to detect that this particular image is matching with the image that we have submitted. Next we have pages with matching images. Here, so if we go into this particular page where we can create templates by uploading any image, and in this particular page we can find this image, and Vision API is able to detect that this is the image that we have sent in the request. In the similar way, we have multiple URLs that are detected where the image present in the URL might be matching with the image present in the request. Next we have visually similar images. So if I click on this link, so we have these images which visually look similar. There is a clear sky, there are mountains in the background, there are trees in the background, and the person is riding a cycle. So there are few visually similar images detected for this particular image. Next we have best guess labels. So this is one such label which resonates most with the image that is detected after searching to the web. Next we have object annotations detected. So here we have object name to be tire and the score associated with it, and then we have the bounding poly where we get the coordinates which we can use to locate this particular object. We have another object with name kid bike and person, shorts, shoe, tire, and so these are few of the objects that are detected from Vision API for this image. Next we hop on to BigQuery and see how the results are stored in the table. BigQuery is Google Cloud's fully managed serverless data warehouse that enables scalable analysis over petabytes of data. It is a platform as a service that supports querying using SQL. It also has built-in machine learning capabilities. The created BigQuery table can be connected to a data visualization tool for further analysis. Here in this table, we capture the image path or the URL and generated labels, landmarks, as well as the confidence score returned from Vision API. I have a table created in BigQuery with the following schema. The field image data holds the path to the image or the URL of the image. Next we have face annotations holding the features that are detected for the faces in the image. Next we have landmark annotations, logo annotations, label and text annotations, each of them holding the relevant information like description, score. Now we will look into the information extracted from Vision API for this image. In image data, we have the path to the image. Next, we have the face annotations detected. Here we have information on the bounding polygon around the image. This provides us with the information on the coordinates, which helps us to identify or locate the face in the image. Next, we have detection confidence. This value measures how confident the Vision API is in detecting the presence of the face within the image. Vision API has detected 2 faces, hence we have a confidence score for each of the face detected. Next we have landmarking confidence. Vision API is able to detect the facial features like left eye, right eye, eyebrow, midpoint between eyes, nose, lip, and other facial features. It also provides the position of it in the face. Regarding this, we have a landmarking confidence. This refers to the score associated with the identified facial features. Next, we have emotion attributes like joy, likelihood, sorrow, anger, and surprise. And each of these emotion attributes are associated with the likelihood value. For the first face that is detected, the joy likelihood is very unlikely, and for the other, it is likely. The sorrow and anger likelihood values are very unlikely, which resonates with the image. And for the surprise likelihood, we have unlikely for the first phase and the very unlikely for the second. There are no landmarks and logos detected in the image. Next, we have few label detected from the image like sky, tire, smile, which is the description of the label, and associated with the confidence score. As there is no text present in the image, the text annotations is also null. We can use structured logs and error reporting API in the code, and we can record the errors that are encountered while processing the image. So here we have few logs that are recorded in cloud logging. So I have entered cloud logging, and on clicking on the logs explorer, I have mentioned this filter vision.googleapis.com, and there are few results that are shown. So we will look into one such log entry. So here we have the proto payload, which indicates the type to be the audit log. Then we have the authentication info, authorization info. Next we have the request. So here we have one single request in the list, and this particular request has features 12 features that needs to be detected for the image. So if we go inside, we have the type to be face detection, we have the type landmark detection, and other feature types. We also have the service name to be vision.googleapis.com. So using this we can filter for the results. Next we have the request metadata as well as the resource info. So here we get more information about the project ID, method, and service.
Yeah, really, it was an insightful demo. Well explained, well detailed. So maybe everyone, if you wanna try it, here is the link. Just 1 minute. I already put it the link. It's Vision AI, and then click try it. And other rest, Tanya, we have two questions from one of the participants. So Stufa is asking, is the 4 megabytes limited only related to this demo? If not, is the mean that I can use larger image in the Cloud Vision API? So,
So yeah, actually, it has a limitation of like it we cannot exceed the image size of more than 4 MB. So we need to reduce the image size, but also it has limitations if we reduce the image size because it reduces the quality of the image. So
um,
unfortunately, we have the image size limit that is 4 MB as of now.
even for enterprise and maybe premium accounts, it's 4 megabytes. This is the
No,
maybe
no,
the
no, it's
largest
not.
image.
No, no. For now, the image size is 4 MB for all the like for everyone. Yeah, and we
Okay,
have to do it manually as of now.
okay, okay. Thanks a lot, Tanya. So yeah, so I guess we can go next if, for the
Yeah, I'm
resources.
just trying to remove it. How? Yeah, is it removed now?
Yeah, it's not
Yeah, it's
removed. Yeah.
so yeah. So I am left with my last slide. That is the resources on what we have next.
Mm-hmm.
Just a second.
Okay.
Yeah, so like these are the two communities, and we have first of all, it's like the first is the Google Cloud community where you can join, learn, and engage with the community. And second is please share your feedback, questions, and ideas for the future sessions and even for this session. And I was in a bit hurry today because like it's too late here. It's like 1:30 a.m. in the night right now. So I'm sorry, I'll not be able to take up more questions up
Thanks
there,
a lot,
and I
Tanya.
have to wrap
Thanks
up.
for your engagement. Anyways.
You're welcome. Thanks a lot.
Um, Okay, I think the last questions we already taken from about the size image. I guess we are good. So thanks a lot, Tanya.
Yeah,
Thanks.
thank you so
And
much. I hope the session was informative, and I provided some information that was helpful to every one of you.
okay, thank you.
Yeah.
Did you attend maybe Cloud Next this year? You attend Cloud Next. You attended Cloud Next this year or no?
No, actually, I was not able to attend it, unfortunately, due to some personal reasons. So, no.
It's okay. Maybe I'd like to share my experience. I was present at Google Cloud Next in London, and literally it was a good opportunity that maybe contains maybe all the ecosystem, cloud ecosystem, companies, developers, Googlers, speakers. It was really great. And yeah, maybe the way I like the more with Google Cloud as a cloud provider, it's that it's somehow dedicated to developers. So developers can use it, can try some APIs, can try some services, not only limited to maybe partners or enterprise and so on. So yeah, I encourage maybe everyone to try the presented the existed demos and services to try. And thanks for sharing the resources. Thanks for your time, Tanya, and see you. Thank you.
You're welcome. Thank you so much for inviting me here.
Thank you. Bye bye.
Bye bye.
So يعطيكم الصحة الناس الكل. It was Cloud Next Extended 2023 by GDG Sousse. Okay, Zainab, you can ask. Maybe. Yes, exactly. Actually, Tanya is a cloud engineer at Google India, and yeah, so this is it. It's basically you can just search on her about her in LinkedIn, maybe in Twitter, Tanya Sharma, as mentioned in the beginning of the video. Okay, I can came back to the whole team. Unfortunately, they weren't with us today. Tonight, but just Harsha Pira, who prepared the demo for us, Tanya, who managed the slides and the presentation. And yeah, thank you, Zainab. I hope that I answered your question. And so ناس الكل again يعطيكم الصحة. Thanks for your time. Thanks for following the community. Feel free to reach out to us في السوشيال ميديا الكل، سواء على تويتر، على لينكدين، على فيسبوك and يوتيوب. كيف كان عندكم دي كيستيون تحبوا تسألوهم أكثر بالنسبة للسيشن هذه. Feel free to put a comment في اليوتيوب channel. Sinon, if you maybe تحبوا other sessions, other events, other maybe guests تحبوا يكونوا معنا موجودين, just قولوا لنا, we'll try our best باش يكونوا موجودين معنا. Thanks a lot. It was me, ابتسام حتاب, so organizer في GDG Sousse, Women Tech Maker Ambassador, and see you in the next. Bye bye.